Okay, today is January 24th, 2012, Chapter 6 test. I kind of cut the page off a little there just because we have to zoom in. We're going to start with question number 9. Okay? I'm going to go on a separate page to work out everything you needed to for this. Question number 6 from your test was an exponent question that you were to simplify. So the base of this number was h. Because we don't know what h is, our final answer is going to be in the base of h. It was a simplified question, so we want it as one exponent to a power. Okay? So we had to simplify everything in this question. Now, there are two ways we could go about doing this. According to BEDMAS, what do we deal with first? Brackets. So because we deal with the brackets first, we're going to deal with this rule here. This is multiplying two exponents. When we multiply two exponents, we're doing the multiplication rule. So we just combine them to have the same base, and we add the two exponents themselves. So what is negative 1? H negative 1 plus 6. Power of negative 6, H2, divided by H at 13. What is negative 1 plus 6? 5, that's right. So the first bracket simplifies to h to the power of 5 to the power of negative 6 times h squared divided by h to the power of 13. Okay? Now, again, according to BEDMAS, what's the next thing we take care of? Exponents. Okay? Now, these are all exponents, but technically this exponent is to the power of another number. So that is considered in itself an exponent. So this is a power of a power, which is this rule over here. When we have a power of a power, that means we're going to multiply the two exponents by each other. So we have h to the power of 5 times negative 6 multiplied by h to the power of 2 divided by h 13. What is 5 times negative 6? Negative what? 30. Good. So this simplifies to h to the power of negative 30, so negative times a positive, times h to the power of 2, divided by h to 13. Now, some people got confused here. Again, according to BEDMAS, there's only really two more operations left. We have a multiplication and a division. When we have multiplication and division in BEDMAS, which comes first? Anyone know? Whichever's first in the row. Okay, they're technically equals. So if we were to rewrite this question, okay, I want you to know it would look like this: h to the power of negative 30, okay, times h squared, and then next would become divided by, or a division sign like this, h 13. So again, according to BEDMAS, whatever comes first, we're going to deal with the multiplication first, because when we're looking left to right, the way we read in English, that comes first. I could technically deal with it together, but we're going to do it like this. So, we have let's talk about what rule this is. This is multiplying the two numbers together. So when we are multiplying the numbers together, we add the exponents so that we have the same base. H to the power of negative 30 plus 2 divided by h to the 13. What's negative 30 plus 2? What is it? H to the negative 28 divided by h to the 13. When we divide numbers, we talk about our division rule. So we've gone through pretty much all the exponent rules here. We're going to subtract the two exponents from each other. So we get negative 28 subtract 13. Negative 28 subtract 13. Anyone know what it is? Negative 41 was our answer in the end here. So our answer to number 6, when we scroll back up to the top, we would left it as h to the power of negative 41. If you want to see that, that was 28 negative subtract 13. Negative 41. Okay, question 12b from your test asks you to estimate, okay, that was a key word here. Estimate the values of 3 to the power of a half, 3 to the power of 3 over 2, and 3 to the power of 5 over 2. Many of you punched it in a calculator and gave me an answer to like the 5th decimal place. There's no way you estimated that number. Okay? What I wanted you to do was look at the graph we had above and give me an approximation of what the numbers were equal to. Now, one way you could have done this was changing these to decimals so that we know this is 1.5 and this would be 2.5. So these represented the x values. This was 3 to the power of x. So when x is 0.5, which is this spot here, I should fill in these numbers on the side just so you can see them. This is 1. Hold on. Okay, so we're looking for 0.5 to start off here. Okay? So our 0.5 means we're talking about between these two numbers here. We have our 0.5. Our 0.5 looks like, here's 3, which is when x is 1. 0 technically gives us a 1 value. So our 0.5 could have been estimated to be roughly 2, maybe a 2.2, something like that. So as an estimation, I wanted some number that was approximately 2, something around there. A decimal did not need to go up to like 5 decimal places in terms of your answer. Okay? Yeah. I think it was less than 2 or a little above 2, whichever way you lined it up on the graph. Okay? Maybe you wrote it as 1.9, 2.2. Something like that would have been acceptable as an estimation. Okay? 1.5. That is between 1 and 2. Now, the reason I use these as references is because I know exactly what they're equal to. Okay? 3 to the power of 1 is 3. 3 to the power of 2. That is not lined up right. Alright, sorry about that. We fixed the scale. So it was every 4 is what happened at the bottom here. So if this is 1, 3 to the power of 1 gives us our value of 3. We did know that. 3 to the power of 1 is 3. Okay? So a half would have been probably roughly here. So estimated as a little less than 2, sorry, would have been better. Okay? 1.7, 1.5, 1.9, something around there would have been a good estimation. Okay? Something like this. Now, like we were saying before, we use these as reference points because we know the values of them. 3 to the power of 2, as we go up, is 9. So I know that my answer is obviously going to have to be between 3 and 9. I'm looking for halfway between. So when I go up on this graph, it looks like it's almost 6. What it looks like there? Well, I think I did go high. I think it should be close to a 5. Yeah. Sorry, this is a bit far away for me to read. Yeah. Oh, you know what I should be doing? Straight lines. That makes sense. There we go. That makes sense. There we go. So we have a straight line going up. Yeah, that looks like it's hitting more at 5 than anything else. So we draw the next straight line. So something approximated around the number 5 would have been a good answer. Okay, so we're talking about approximately 5. Something around there would have been acceptable as an answer. And again, the same idea, 3.25. If you would have drawn a straight line up, we'll do this one in blue. And it goes way up there. All right, so when you approximate this, something over 15 would probably be a good approximation. 15.2, something like that. Something like that.